Monte Carlo Simulation. Monte Carlo is the name of the city in Europe where the big casino is located. So that's where the name came from, and here's a die. So what is Monte Carlo Simulation? This is an important math tool to solve the problem, mostly using computer. So it's a very complicated problem. Sometimes you can't really analyze it by mathematics. We use Monte Carlo simulation, and that's involved the probability in there. So it's often necessary to simulate with random number. So example is random walk, atomic ray, traffic analysis, etc. Even the gambling, we can analyze, see if gambling model is correct. For example, what do you do when you got 13 in the blackjack? Do you hit or stand? How about 14? Depend on the dealer's hand. So you make the model, see what you believe it's right things to do. Then you do the Monte Carlo simulation. You can tell whether you lose or win. This very complicated math problem. Sometimes it's very effective, and often computer is used. But a lot of people don't know the random number is not really random. There are many different kinds of random number. The uniform random number is you get the number 0.356, 0.728, so and so. Okay, you get those uniformly distributed random number. This is very important. The computer provides this as a function call, so you can use that. But sometimes you need distributed random number. For example, the Poisson distribution or Gaussian distribution, some skewed distribution. You get more random number around here than the edge. Okay, so depend on the model, you have to select the correct kind of random number to do the simulation. For example, if you use the two dice, the most often happen is 7, and 2 and 12 is rare. Okay, so you use this number to do simulation, then you have a skewed distribution of random. The result will be different. So the nature of random number is very important, and also the period of random number. Okay, the random number generated by computer is not pure random number. It doesn't generate a random number forever. It's generate long sequence and repeat. So there's no point of repeating same simulation over again. So you have to understand lots about the random number you use in the function call in each computer, and the distribution. You have to evaluate, test, see what kind of random number you're getting first. Okay, now you set the model. This is a computer program. So when some input come, you're supposed to do this and this and this. If number is this, if number is this. So this is output. Okay, so you get the output monitoring, and you need another things monitoring. That means the random number is generated properly or not, kind of monitoring you need. And together with output could be distribution of the result you're monitoring. So that's a computer model is programmed and generate a bunch of random numbers, and you feed this random number to the program, see what's happened to the output. Okay, that's basically Monte Carlo. So Monte Carlo is kind of compromise. It's a very complex problem. Like here you have if statement, you have some kind of non-elementary function. This combination of those, it's very complicated model. You cannot really analyze by mathematics. Okay, so you set the model and feed the random number and see what happened. You see at least the result, how it look like, and it's very effective for some application. For example, the random walk. Okay, drunken man walk random direction. Okay, and see how far he can get. So you monitor the distance. So it's going to be, distribution will be like that, probably. So if you have a model slightly skewed, for example, say drunken man see the bar here, right? Then he tend to go toward the bar, but he's drunken, so still go randomly. Then skew will be like that. Okay, so simulation with random number and keep the data, the distance in this case, and make a distribution of the distance, and you can analyze the effect of having a bar here, right? So this is just an example. You can have all kind of model you can create. So second example here is very scientific one. Scintillation counters for the high energy particle. It's when high energy beam come in and hit the atom, it scatter, and depend on this scattering angle, it's generated different light, frequency light. If scatters very hard, then high energy, like a blue light. If scatter only slightly, then it's more red light. So you can get the light frequency recorded, and it's going to get the spectrum of light frequency. And by looking at this, the energy beam level can be monitored. For example, if the shape is like that, then this probably gamma ray energy level is certain level. If it's become more skewed like that, the energy level is low. So we can tell the energy level of the gamma ray by monitoring spectrum. So that's also this scattering high energy beam is a very complicated equation, and it's very difficult to analyze by mathematics. It's use Monte Carlo simulation. It gives a very nice result. Okay, this is just two examples. So Monte Carlo simulation is often used in science to get the answer from the very complex model using random number. Okay, I hope you enjoy listening this. Please check out the video too, and if you like, subscribe.